I'm Sabrika and I'll be presenting Joyverse, a real-time emotion-aware platform designed to support learning in children through interactive games. The aim is to recognize how a child is feeling while they play and adjust the experience to keep it both supportive and engaging. We worked on connecting different parts of the application: the front end, the middleware using Express.js, and the Python backend for emotion recognition. Through this, we gained experience handling real time video input and learned how to process that data so it can be used by a machine learning model. We also learned how to set up a machine learning model as an API service and how to make sure data moves smoothly between each part of the application. One important learning was how to manage state so that the game and user progress remain consistent. Several new features were added to improve how the platform works for both therapists and children. We introduced a super admin dashboard. This allows admins to securely create and manage therapist accounts. For children, we replaced open signups with a code based registration system. Each therapist can now generate a unique code to register the children assigned to them. This adds an extra layer of safety and control. We also added progress tracking so that every game session is recorded. This helps in monitoring how each child is responding and improving over time. Our primary focus was on using a custom built model based on face mesh, which gives us detailed facial landmarks. But since browser support can vary, we also included Face API as a fallback to ensure reliability across devices. Another challenge was implementing adaptive learning, changing the game's difficulty in real time based not just on how the child plays, but also on how they seem to feel. Managing session data and keeping performance smooth while running face detection and game logic at the same time was also a key technical task. For emotion recognition, we used facial landmarks as primary input. These were extracted using a custom implementation based on face mesh, which allowed us to capture detailed facial features. To ensure broader device support, Face API was included as a fallback in case of browser or hardware limitations. The landmark data is passed to a custom transformer based model developed using PyTorch. This model was designed specifically for our use case, allowing us to control the architecture and training process to suit real time emotion detection. The choice of a transformer architecture enabled us to model temporal patterns in facial expressions more effectively, which is essential in dynamic, interactive applications. Before finalizing the current model, we explored several other approaches. We considered pre-trained emotion models from platforms like Hugging Face and other deep learning libraries. However, these models often required raw image input, offered limited transparency, and were not easily adaptable to our facial landmark-based approach. Custom training gave us more flexibility and better alignment with our application goals. Commercial facial analysis APIs were also evaluated, but they posed concerns around cost and data privacy. Support vector machines were tested as well. They were easy to implement, but lacked the capacity to capture the complexity in facial landmark data, especially when emotions were subtle or overlapping. Currently, all components, the front-end, Express middleware, Flask backend, and MongoDB database run on a single server. This made testing and development simpler. For future stages, we plan to shift to container-based deployment using Docker, which will make the platform easier to manage and scale on cloud platforms. I'll be demonstrating Joyverse, a therapeutic word search game. Let's start by creating a therapist account through the Super Admin dashboard. First, I'll log into the Super Admin dashboard. This dashboard has constant username and password, which are only known to the Super Admin. I am now creating a new therapist, entering username and password. Here we can see the interface for managing the therapist list. Now, let's switch to the therapist perspective. I'll log in using the credentials we just created.
In the therapist dashboard, we can see several options. Let's create a new child profile. We'll enter the child's name and add the child. I will now assign 3 different themes from 5 here so that these themes will determine the word list and visual environments in the game. For Peter, I'll be selecting underwater, space and kitchen. This therapist code is used to log in for the child to play the game. We can log in using the therapist code as password for the child to play the games. Before starting, the system initializes the emotion detection system. You can see it's using face mesh for real-time emotion tracking as default. The first puzzle appears with an underwater theme. The background and the word list are themed accordingly. The game is designed to be intuitive. Click and drag to select the letters. Match the word with the displayed image. The system tracks emotions in real time. As you can see, I also have the option to change the model in the backend, which will change the emotion tracking system. Now Face API is the model which is detecting my emotions. As I play the game is tracking my emotional responses, adjusting difficulty based on performances, switching themes with negative emotions are detected. The difficulty system ensures that the game remains challenging but not frustrating. After completing several puzzles, we can check the sessions and the emotion analysis throughout the session of the child, which are available in the therapist dashboard. This is the session's history. And this represents the emotion distributed across all the sessions. Now let's verify how the data is stored. I'll check the MongoDB database to show you. The therapist has a child named Peter, and here we can see the current assigned themes, and the played puzzles. This data helps therapists monitor progress and adjust therapy strategies accordingly.
These code snippets demonstrate how different parts of the application communicate to support real-time emotion-based interaction. The front-end sending game event to the backend, front-end sending face landmarks to ExpressJS and receiving processed emotion, model wrapped in Flask API, auto-adjusting difficulty based on player performance with right or wrong streaks, receiving landmarks from frontend and sending them back to the frontend after processing through the model, loading face detection models, face API or face mesh with real-time status updates. Thank you.